What we'd like to do with Polytrack is use the tram and some exciting sensors that we want to put on the tram to analyse what's going on the track so that we can make the track maintenance more efficient. Well, I find I do a lot of engaging with competitions, and they are a really useful catalyst. There are lots of great ideas bubbling around, and there are lots of big challenges that companies have, and the competition can provide the catalyst to say, right, it's this team that we need to assemble for this challenge, and then there's the added challenge of meeting the competition, but that it provides the catalyst. WM5G funding had lots of very useful features. It had a railway option. I only deal with railways or tramways, so it needed to be in rail, and 5G is very exciting because of where we are with data science as a world, and I've been engaging with some leading data science people who need so much more data and can accommodate so much more data, so that was the really big opportunity for this. And the West Midlands is really good because we needed a very practical place where we could make this application. Because really critical to this project is that it's vertically integrated. We need to have someone where they've got both vehicles and track, and they've got an overview of both of them in one system to be able to do the experiment and to see if it works, and also to be able to reap the benefits more easily. Well, specifically with our Polytrack project, it enables us to have more data. And it's a bit like the old thing about looking for needles in a haystack. We're trying to identify on the tram, when people get on and off the tram and people move around the tram, they will obviously move the tram vehicle. And we don't want to see those movements. We're not interested in those. We're trying to pinpoint exactly what's going on, not between the actual tram and the track. And it's quite hard to identify that amongst masses and masses of straw, but it actually helps to have a lot more straw in your haystack to be able to then characterise it and do the Fourier transforms and all the posh engineering analysis to pick out the bits that we're looking for. So and having lots of runs of that data and having it really reliably, so it's the low latency and the big capacity, even if people are gaming on the tram or something else is going on the network when they're using the network. So we want that level of reliability to be able to gather the data and hopefully see the patterns that we're hoping to see. So the benefit of 5G is particularly in the development phase, because we have to be mindful that there isn't 5G everywhere at the moment. So, and we need a valid commercial case that's widely applicable. So we're looking to have absolutely shed loads of data, it's a technical term, to have lots of data to really get the very precise analysis in the development phase, which is what we're doing during this project. And then beyond that, we hope to be able to sparse out the data once we've identified really clearly what it is we need exactly and what patterns and signatures we're looking for in the data. We hope we might be able to end up delivering it with lower levels of G, so that 4G, there is more 4G network out there initially, so we might well be able to apply it there and build the commercial case there, beyond the deep case that we need to get the technology sorted in the first place. So the Polytrack project is made up of Polychord, who are the data scientists, and they come from having analysed the data on the Planck satellite. So they've been looking at very difficult to interpret data, and they've developed some brand new data science in that field. And they're joined up with people who are gathering the data from the tram, and that's engineering, safety and risk, and they are ESR technology, and they're used to doing this sort of analysis on trains, which is where I've come across them. And they're also joined up then with the track analysis, which is where we have University of Southampton, because we need some direction for understanding what's happening at the track side of the interface. So those are the three key technologists. Then obviously we need the 5G, so that's where we've teamed teamed up with Icamera, who've got a router on the tram to get the 5G off the tram, and BTEE, who are the MNO for us on there. And then beyond Polychord, the data scientists, and ESR, the onboard sensors, and University of Southampton, the track monitoring. And then we've got the router, which is Icamera, to get the 5G off the tram. And we've got BT as our mobile network operator. And then Selic Rail, I'm the subcontractor that puts together the whole team and puts together the commercial case, with absolutely crucially with our key client, who is West Midlands Tramway, who are the first opportunity to have this hopefully a more efficient way of managing their track maintenance. Well, it's a tight timescale because we have got the funding and the team together, and we've been developing an understanding of what it's like, what sort of data we would collect, and whether we might see anything, and how we need to actually make the prototype of sensors. Because obviously, being innovation, none of this has been done before. We don't know if it's possible. That's our key question. So to sort of feel around the possibilities. So the first few months taken doing that, and then we will actually prepare the prototype technology that we'll put on the tramway, and we'll see it then on the tram vehicle, and then we will see how that works on the tramway by analysing the data spots, and that will be our 3-month trial period using the 5G network to get the big data off. And then we've got the analysis of that, which will be as we're going along, and more some to really by Christmas to get it all coherent, hopefully. And then we'll be looking at how we then identify what to do with this. So what does that mean? What does it mean for the track twist and those sort of parameters about track maintenance, and how will that be useful? And that's our phase in the last couple of months, in January, February, to build a credible way of using this, which obviously then builds to our commercial case, which is where the matched investment of the companies is making. So what we're trying to do with 5G is say, wow, we could get cuter about doing the maintenance here. We could get cuter about our understanding of how vehicles dynamically behave when they're on rails. It's an age-old problem. Stevenson invented it when he was a lad 200 years ago, and we're at how can we optimise this? And it's still an ongoing opportunity to get better at that optimisation and to be very targeted in our maintenance. That's building on some research that the University of Southampton have done, and say we need to find out where we need to do that very targeted maintenance on the track. So it's to get that very precise alignment and to find, hopefully, the needle in the haystack that shows us what it is that we can do and where. And then we will be able to not only make the maintenance more efficient, but also increase the life of the assets, to increase the life of the track so that it will last longer, so that's more cost effective, and also of the trams. And then to bring this back into how tramways, track is designed, and also in how vehicles are designed, so that we can then get cuter about our designs for these things into the longer term. So we see it's a big opportunity to really pinpoint and target how we could make this interface better, which will then unlock a lot more efficiency and effectiveness. Polytrack's interesting because it's both a product, a physical bunch of kit that you're going to be able to put on your tram vehicle or your rail vehicle that does the sensing of what's going on in your tram. And it's also a service in that when we suck that off and analyse it using 5G, we will then, and apply the data science to it, we're looking to provide your engineers, particularly your track engineers, with on your railway, on your tramway, with the information that says, oh, this bit's going to need this sort of maintenance at this time, and it can get very precise about that in order to optimise it. So Polytrack's partly a product and partly a service, and you put it all together and it makes railways and tramways more efficient. To be perfectly honest, we've been focused on Polytrack and our own project, and we're just not aware enough about what the other competition winners are doing. So we're really excited to find out more about them and then identify synergies that going forward from there. Beyond this, obviously, the first application in West Midlands Metro, so it's a tramway application, we are very keen to see this applied to the mainline railway. University of Southampton have a lot of experience there, as does ESR Technology. And we're really keen to see that there's a commercial case there. It's something, it's kind of a holy grail that's not been achieved on railways. And although it comes across a contractual boundary, it's such an engineering important interface that we think there's lots of scope there. So if anyone would like to get in touch, if they can see that they would like to be an early adopter of this, then we'd be delighted to hear from them.